Hello, welcome back, PlayBASIC coders. Let's take a quick look at a new source code example. This one is doing something kind of interesting. Let's just run it, we'll have a look. So this ran through the slibs folder, and which is the source libs folder, which comes with PlayBASIC. A bunch of these simple libraries that are presented as source code. What it has done for us is create a list of all the functions that are available in these source codes. So in this case here, it's dumped out as HTML. If we run that again, so we loaded 51 files. We discovered the files, and there are 1,059 functions inside a second. It's done that one there. I didn't write this to do PlayBASIC stuff. I wrote this to do with the website stuff, but the principle works with both. So here it's just giving us for each file it looks at. In this case here, well, it's the Flex GUI. These are the functions, what line number these things are on. Ideally, the idea of this, well, what you'd expand this to do would be have it load the document or even grab the function from that location if you wanted it, which really is just a few steps away from what this already does. In my case, I needed something to give a source level overview of what functions existed and where they are, and are there any duplicates of things, and there are generally. Alright, I'll flip back to here. Let's try the Learning Edition. So running through all of the projects inside the Learning Project pack. So there are 526 files that were loaded and 1,008 functions were discovered. Have to reload through the browser. It's updated the file for us. It's pretty handy. I've done this before and I could not find the program to save my life, so I ended up spending this afternoon and yesterday cobbling together this thing that I've already written before. I don't like redoing things I've done before. It kind of drives me nuts, particularly if I know I've already done that. I just couldn't find it. As per usual, just could not find it. So I'll make sure I'll put this one up on the forum, so that should make it easier to discover in the future. The actual program itself is pretty straightforward. So we've got, in this case here, we've got a thing gets all the files in the path we supply it. It's able to ignore paths as well, which is pretty handy. This grabs all the files. We cull away any file names that I don't want, because there may be files there that are of the same type, but maybe they're not useful for what I'm trying to do. Process file things just runs through the list of files that was discovered, loads them. Let's have a look. So here we just, very simple function, we're going through the array, grabbing the file name, trying to load the thing, and that's what does the work, and then we're just displaying this out to the screen so the user has something to look at while it's doing this job. The phrase function here does the work where it discovers the functions inside the file. We'll take a look at it. So, do we exist? If we don't, return, who cares? Display loading, load the source code into a string, split it, remove any character 13s, split the rows into this array, like so, skim through the array, which is now pretty much a map of each line. Grab the string, check, is it an empty row? Who knows? If it's not an empty row, we skim through it character by character, trying to look to classify any words. So we're doing a very preliminary kind of phrase, really. Actually, that should be 2, by the way. If it's characters in the bottom 32, ASCII characters below 32, just ignore them. We don't care about those in here. If we have an underscore, this might be the start of a word. Lowercase characters, it's a word. Uppercase, was treated as a word. So we scan ahead using this character table here, find the imposition of this block, and then grab the word and check whether it's either a function or a p sub in this particular case. With an expression like this, normally I wouldn't do that. Normally I would do one lower and do the comparison twice, but I'm not really concerned about performance in this. I just wanted to do a pretty good job, skim through, get the information, and then be able to search and look at the function list later. Which, you probably had the same situation as me. It's annoying sometimes when you want to treat unrelated code as if it's in one big blob so you can find that function you were looking for. I don't know how many times I've looked up certain things and gone, where is that file? Where was that function I wrote that did that thing? So frustrating sometimes. This is the kind of purpose of this little tool here. So we're doing a quick phrase, we're looking for those keywords, and we're trying to skim past the rest of it, so to avoid looking inside obvious quotes. Now there are situations where we probably should treat this more seriously. Like if we find a remark statement here, we should skip this because the rest of the line is actually it's inside a remark. Because old school BASIC has this. Whereas the way it's set up at the moment is if we had rem and then function, hello world, it would actually move straight past the remark statement, find this and go, okay, that's a declaration there, even though it's been remarked out. So there's a bit of a shortcoming there as well. And it doesn't actually support multi-line remark blocks, so rem blocks in general. But for what I needed to do, it does the thing I needed to do. You can expand it to do that if you want, but that's up to you. This is pretty much the tool. The file functions here are the kind of standard skimming through folders. For those people in the cheap seats, it doesn't use recursion, by the way. I'm not a big fan of recursion for things like this, but just do a quick save of that. So we've got some print statements in it. We've got a couple of functions there to load a file into a string. This one here does a save. Just if it exists, we delete it. We're doing a load. We have a restriction on the file size, apparently, for some reason. I don't know why. We're just assuming that these files are bigger than 32 characters. Well, whatever. In here, this is the discover routine, and this uses a callback to a user-defined function to render the screen every now and then for when this process is running. Because if you gave this, if you just pointed this at like the base, your C drive or whatever, it could take who knows how long to skim through that. It's hard to imagine how many files and folders that are actually on a C drive. It's not like the kind of thing you want people to wait for. So without any kind of response, so that's what this is doing actually. If I didn't call this and we gave it the folder of a location that has hundreds of thousands of files or millions of files, the application would just be sitting there doing nothing. So we want some response back to the user. this function it calls just draws the screen and gives us the amount of files and folders we've currently been discovered. Refreshes that anyway. So the actual function that does this is down here. So we have two basic arrays that this is keeping track of. A list of files that we've discovered already and a list of folders that have been uncovered. So at the end of each sweep, if we have any folders in the folders array, we just grab a new folder off the end and restart. Just keep doing that thing over and over again. So we don't need to be recursive. So a little scanned folder, we've got the files array, the folders, and ignore list there. We move to the path, we just skim through, check for file names we don't care about. If it isn't one of those, we continue through. Is it something, a file or a path that we should ignore anyway? So you can exclude certain subfolders if you want to. This one has that, whereas older versions of this function don't do that. I think this has some logic problems as well. So I grabbed this from the forum, and it was an older version of this code. I obviously had written and uploaded, thinking I'll grab that when I need it later on. And at some point I've fixed it in another version. This is one of the ones I was trying to find actually. I couldn't find this function in my local hard drive. I was thinking, what the hell happened to it? You know, it's probably still there, but it's just nice to have something that runs through, can grab the function names, and so you can go, oh, that's where it is. Anyway, so we're sweeping through the folder here, where in this case I'm just remembering files that are PBA files, that are PlayBASIC source files, and folders. If it's not that, we just skip past, we don't care. We skip on to the next file in this folder until we've come to the end, and then we just keep going. When this function concludes, we pass back the new upper and lower limits for the number of files and folders, and we just keep looping through here until this is 0. There are no more folders to discover. Alright, so a little phraser up here has two parts to it pretty much. We've got a function to add our function details to a global list of function names. In this case it's just an array, it's just resizing the array as we need it. So it's declared up front, declaration, our array and our count. It's a bit cheesy because I wasn't really thinking about giving this a sort of real world use case, but anyway, get the size of this array currently is, well, adding one overflow that size. If it does, let's just add another 4096 space for those things to it. So we're not doing a refresh of that array every single time we add something. And from the caller's perspective of remember function, it doesn't have to worry about how big that thing is. We don't care. I could have just made this a list actually, a linked list. Yeah, whatever. Anyway, so we're just storing the name of the function, its parameter as a string, the line number it occurs on, and the source file that it actually was located within. When we go back to here, there's processing stuff. Where are we at? And we export this out as HTML. So we've got this file. We've got our template, which is just a text file, nothing special about it. I've just inserted some key, some tokens that I'm going to replace or cut these things out of. So when I load the template, I grab the block of code between here and remove it. I grab this function section here from it and remove that, and then as we're outputting skimming through the function list, every time I find a function, I grab this bit of text, which is the HTML, inject the name into it, put the parameters, etc., all through it, tack them all together, and then dump out each block inside this block, creating this. That's this section here. So title, and we have our functions underneath that. I'm not going to say it's a great method, but it look, for what I wanted to do, it's doing the job pretty well, and for most uses, I would say it's probably an okay solution. I was definitely thinking about having a display where you could just get it to load, where you could just get to load the document or grab that function directly from something and compare it with another version, which would be very handy. I mean, who knows? If you want to do those things, you're more than welcome to take the code and do something else. Add to it and customize it the way you need to. By posting this, I'm pretty much saying I'm done with this, and I need to move on and get to the next thing. Hopefully you find this useful, but let's go through the generation process. So once we have our list of functions, this is generating the HTML file. We're loading the template, which is this text file here, into a string. We're inserting our page title. We're just replacing that inside, which is already in that text file. We're grabbing this section here from inside here and removing it. So we're passing this in, telling it to cut out the section which is surrounded by the demo tags. Demo, we don't need that for our purposes, but it's just helpful to have that there. So I remember actually what things do what. So we're pulling it out, going through and grabbing the function template, the source code block template as a chunk of string. We're running through our array of functions that we discovered in the previous pass. If the function has nothing in it, just skip over it. It may have been deleted, perhaps. Grab the source file of this function and check, are we still dumping from the same source file? If not, we do the block insertion of the HTML block, dump it out to our HTML cache. So each section as we go through is being pieced together in each function name here. It's been pieced together as a little bit of HTML, and then at the conclusion of each section at the end of this file, we're just storing the source name, the function name, the parameters, and the location. So we're scanning through anytime that our current function has a different source location than the previous one, we've changed files. We need to generate this whole block. But as we're skimming through, we're just adding each source file discovered into this block variable. So it's doing this here. It's using a template we grabbed earlier. We're inserting our function name into that template, inserting our parameters into the template, and our line number. Now that's one line of this. And the styling is already part of that template. So our generator doesn't actually need to generate HTML. It's just grabbing this block of text, customizing it and spitting it out. It doesn't really know it's even HTML at all. It's just doing a text operation as far as it is concerned. So when we find a situation where the current source block and the previous one don't match, we have to output a block of this, which is these larger chunks here, where this rounded rectangle is, and the source file heading, those kind of things are in that, and that's what that's doing. We're dumping that. Once we've inserted the previous list of functions that were discovered into this section, we're then adding that onto a global accumulation of all of the blocks we've found so far, which is ultimately is then inserted back into the main template. So it's just a bunch of insertions and replacements that build the page. It's nothing special at all. The styling actually is just pre-computed. So it's got a standard page. Here's our body. There's file groups, file title. Yeah, just we don't have to do any of that in our code, and by using this a straight sort of compositing method rather than something that generates HTML, we're not even aware of those things. That's why I've used this as a template. I'm just going, okay, just give me this block here as a chunk of text. I'll insert the name of the function with an insert, an in string, or a place, I should say, and its line number, like that. Then dump that block out as HTML. Dump that block out string after string after string, and when we find the last one, we just insert all of the discovered functions, get replaced into here, so they appear inside this class, this particular style, block of classes, I should sort of call it. And then ultimately that chunk is inserted back into the overall document in here, so it all appears in this section. I hope that makes some sense. Probably doesn't, but you know, look. Anyway, I think that's probably enough for this example. I think hopefully you've got an idea of what this thing does and what you can do with it, and hopefully you find something useful. Maybe find a use for it with what you're doing. Anyway, thanks for watching. I'll see you next time. Bye.